with everything being new, everything's page 1, so I got to be a little more specific here. But just a couple of quick reminders and some advice on the steps we might want to take when we're dealing with some of these. So when we're solving, this is just in general, we kind of know this. We got to make sure that we isolate the variable, or sometimes you'll hear teachers say, hey, get the variable by itself. You're like, Hardy, we've been doing this for how many years now? I know, but sometimes I need gentle reminders of things just to kind of get back into the swing of things. So if we do something to one side of the equation, you must do it to both. Like we are talking straight up mathematical equality here. If I minus from one side, I'm minusing from both. We got to play it equal. So when this is going on, and again, some of this is more optional, but some of it you really want to make sure that you've got. So first job is always to simplify each side. And there's two ways we can do that. If you already have multiple terms, we got done with that last cycle, where there are like terms, x's, numbers, put them together. I'm going to put this too. Combine like terms on the same side of the equal sign. Okay, if they're on opposite sides, we got a little bit different of a job to do. And then we need to distribute if we see any parentheses working. Okay? Once those two things are taken care of, now we can go into the more traditional, how do I solve my equation? So if there's variables on both sides, move them to the same side, but I'm going to add a little something here. Okay, using opposites. So like if I have negative 4x and I need to get it to the other side, I'm going to add 4x and things like that. But that only happens when they're on both sides. Like terms, we don't have to do that. And we'll chat about that some as we get going along here. If there's constants on both sides, did I just... Okay, yeah, that's what... Whoo! Deep breath. If there's constants on both sides, move them all to the other side of the equation, because we want all the variables on one side, we want all the constants on the other. And then we're going to use an inverse or opposite operation to isolate the variable. Now normally that's going to be multiply or divide. But I'm not going to write that there because I don't want us thinking that's the only option that we had. These are very much an it depends thing. And I know I hate that terminology because it's like, oh my gosh, I got a math brain. Let's just do it this one way. But yeah, equations don't roll that way, unfortunately. And so I'm just going to move this up a little because I know I got some of you playing a little catch up here, and that's okay. But what I'm going to stress and why on these first two, we're both going to have situations for step one. And we won't have step one every time. So important to keep that in mind. So I see parentheses. That's always job one, no matter when I see them. So we're going to distribute. We're going to multiply our 3 through there first. And get that set. That takes care of step one because my terms here, okay, those, I do have multiple constants. They're not on the same side. I'm not just putting them together. This is where all my variables are on one side. Okay, we're good. If there are constants on both sides, yes, just plain old numbers. Move them all to the other side. So my job here is to get the 3x alone. So I've got to do an opposite of this. Now, everybody's different when it comes to equation solving. Some of you are very comfortable doing steps in your head and just going from like this to this and then the answer, which is fine. But again, there's nothing wrong of, again, doing opposites. The opposite of multiply is to divide. And we get there. So once we've got all of our x's together and working from there, now it's just a big game of opposites. But the one that gets missed the most, surprisingly or not, is number 2. This happens in my Algebra 2 classes that I do. I've even seen it happen with my honors kids a few times. These x's are different than if they're on both sides, like they are in number 3 here. Because here, since these are on the same side, we're just putting them together. Do not do opposites if they're on the same side of the equals. Gotta be cautious of those things. But now it looks just like this one. So I'm going to do it the exact same way I did this one. I'm going to do my opposite as I go. And my opposite of multiply is to divide. We're just taking our time. Watching for things like our signs, making sure that we don't look at that and think we should subtract it instead. Stuff like that. It's going to help me get there. But let me move a little further. These two seem really similar. I see 2 things with x and 2 numbers, but they're not the same. Because this time, the x's are on opposite sides. So, when we have variables on both sides, we have to use opposites to get them together. It does not matter which side you get your x's on. If you minus 6, x, that'd be okay. So I decided I was going to keep my x's on the left. And just after that one step, now again, looks just like the last 2 did. And we just work that out. So this whole section is a bit more of a refresher than anything else. Just kind of prepping us for the applications and some of the other things we can do with these. And so the only thing really that's left as far as these go, oh, parentheses again. Okay. Don't let the half mess with you, because again, we're just cutting each of these in 2. So when we cut each of those in 2, now we're back basically in the same situation that we had over here. Variables on both sides of the equals. We got to fix that. So again, it's positive 2x, so I can subtract. If it was negative, I'd add. And here we go again. You're like, Hardy, this is really repetitive. It can be. It can get tedious at times, for sure. But when you learn to have that attention to detail and the follow-through enough to be able to do these consistently and not have errors, that's when you've made it. And that's not just going to be in math class. That's like life thing, okay? Being able to work your way through even when the going gets a little bit stale. So I'm not going to do all of them on the back of this because I don't think we're going to need all of them. We've covered most of what we need to see here, but I do want us to see a couple of things that can get a little weird that I want to make sure don't throw us off. So we're just going to kind of pick and choose here on the back, and then we're going to be good. This is another famous one that messes people up. So I'm actually going to show you something on a sticky note first. Don't write this right away. So I'll see a lot of people look at this one and they'll go, all right, I'm going to minus 4x minus 4x. And then they get here and they think that all cancels out. And then they're like, well, now there's nothing left. So this is no solution, which is not the case. Because even if those did cancel out, I would still have a 0 there and I could add 8 and move on. But there's an easier way. Here's the way I would say. If you have a side that just has x on it, get all the x's there. That will make life so much easier. And that's even going to be tempting. You're going to say, ooh, it's like -2. I'm going to add 2. Nope. You're multiplying by -2. So we're going to divide. And we work that out. Okay? So, again, we're just working on keeping those set. So let me ask one other question on the normals. Then I got 2 at the bottom we're going to play with. Because I think, I just saw something. Okay. How do I undo this? Nice. It's like division. A fraction is just division. So we're going to multiply by 6. But here's the thing. On the left side, that 6's whole job is just to cancel that 6 in the denominator. I'm not going to distribute it. The top is going to stay the same. The right side we actually multiply. So again, real quick, it gets looking normal as long as I can remove myself from the temptation. Hardy, could I add 8 here first? Nope. Not while it's in that fraction mode, I can't. So we're always going to look to get rid of those fractions first. That's going to be our key with these. And get ourselves set. So parentheses are always a priority, fractions are a priority, and things as such. All right, the last regular one we're going to take a peek at. Because again, I see it happen often. I'll have people look at this and they'll write, hey, I know what to do. They'll be like, all right, 15. 3 minus 2 is 1. And they'll go this way. Can't do that. Well, why not? Yes. This minus 2, and yes, I'm taking the minus with it, needs to be distributed first. That 3 has nothing to do with what's going on over here. At least not yet. So distribute the -2, multiply that to both my terms. And now I can start to look and say, ooh, same side of the equals. Okay, I got 2 constant terms. I got 2 numbers. We're just going to put them together. No opposites. Ooh, excuse me. Thank you. But now, again, as much as any math problem is normal, we'll get that set. And we'll start rocking this out. And again, if I take my time, sometimes we don't like to take our time. We just want to be done. I get that. But if we take that time to do it well now, it's less time. We got to redo it later. That's about as long as these are going to get most of the time. Okay, if I got to do a little distribute, a little combine like terms, opposites, and kind of do that. So here's the part that's going to start coming up more. Like, I'm going to try and work these in daily, getting you to kind of think through this, because this is real life stuff. Like, normally, life isn't just going to be a math problem. You're going to say, okay, something got messed up here. Where's the problem? So take a moment, look through that work over there, and try to see what may have gone haywire for the student here and how we could fix it. Number 3. Can you see where there's a problem? Oh, we've got something. All right, what do we got?
3.
Okay.
Instead of adding both the 4x and 2x, they minus.
Yep. They did the error which is common, which is, ooh, here they did the oppo. We did the minus 2x. They're on the same side. We don't want to do that. So from here on down, everything got messed up. So here, I'm going to go ahead and fix it. That's just kind of how I operate. So it should be 6x plus 28 equals that. And now we can kind of work it through. So you're like, okay, Hardy, does this mean that when it says that in my homework, you're going to make me not only find the mistake, but also, fix it? Sometimes I will. I'm just making sure I don't make a mistake. That'd be kind of funny. If find the mistake, then I'd make one too. That would, yeah. Ooh, I think we're gonna get fractionally or decimally here. Again, unless I've done something kooky. Let's see. Negative 18 divided by 5. Yep, that's definitely decimally. So always be prepared. Sometimes you may just have to find the error and circle it and be like, no, they messed up. That should have been 6x. Okay, that's cool. But if you're asked to fix it, be prepared to kind of mix that up. All right, we'll just find the mistake on the last one.
Okay, I know the one.
You're ready. Let's do this.
It's the false problem.
Oh,
they did not multiply both sides by 2.
Oh, dear. Yeah, here it looks like we did a plus 5 instead. Oh, my gosh. Learn how to spell, Hardy. Instead of a times 2, which we said earlier. We can't do that until the fraction's taken care of. So here, I'll just get this first step taken care of, and we'll be content. We won't, I promised I wouldn't put you through the whole thing here. So here we would just do 2x minus 5 equals negative 18, and we'd go through. Do make sure, though, on problems like this, that you somehow explain, okay, it's this step. That was perfectly worded out. First step, and what's going on. If we can do that, that's some high-level stuff that we're getting into, and that's the goal here. So, I started wanting to call this Monday. It's not Monday, it's Tuesday, my gosh. Okay. So, job 1 here, I'm just peeking at something. Yep. All right. We're going to be looking at page 1 and 2, and I just noticed something. I'm going to jump in and help on one problem, just one. And I'm going to get you started on it because it was a weird one that we did not see an example of. So hang tight here in the practice. We're going to take one last leap here. We're going to do number 6, or at least I'm going to get you started on it. This is kind of different. So there's a couple of ways you can tackle this. If you want to just deal with the fractions, which we can, we have a calculator, you could just go through and minus 1/3 from each side. But if you're like, oh, fractions, Hardy, okay. If we just want to wipe out the fractions, we're lucky they both have a common denominator. What I can do instead is I can multiply everything by that common denominator, and they're all going to go away, because here, the 3's just cancel and leave me, I got to have the 2 still, with the 2 up top. 3 times negative 6. Again, on the fraction, the 3's just cancel out and leave me with the stuff on top. Now it's pretty normal. So if you run into multiple fractions, that's probably going to be your best escape. If there's one, we can deal with one. But otherwise, we should be good there. So play with some of those on 1 and 2, as I said. I will have all the answers up on Classroom starting tomorrow. I'll get down to the copy room, make a PDF, but I do have a copy of them up here in the front, so if you want to come and look at some stuff as you go or you run into a question, please let me know. I would